Take a look at this machine. On the outside, yeah, it's just a bunch of metal, plastic, and wires. But inside? Inside, there's a conversation happening, a secret language whispered between components at the speed of light, turning this collection of parts into something that can see, decide, and act. What is that secret language?
I mean, really, how does it think? How does it make the choice to turn left instead of right? How does it know for sure that it's picked up an object and not just bumped into a wall? It all comes down to the language it speaks internally.
Whoa. Okay, I know. At first glance, this just looks like a chaotic mess, right? A tangled web of boxes and arrows. But this is our roadmap. This is the secret language, all mapped out. It looks impossible now, but I promise you, by the end of this explainer, we are going to understand every single piece of this puzzle. Let's start at the beginning.
So to make sense of that whole tangled web, we need to start small. It turns out that every single complex thing a robot does is built on just 3 fundamental types of conversation. Let's break them down one by one.
First up is the absolute simplest form of communication. I want you to picture an old-fashioned town crier, standing in the middle of the town square, just shouting out the news for absolutely everyone to hear. Well, in the robot's world, that's what we call a topic. One part of the robot, which we call a publisher, is our town crier. It just broadcasts information out into the void. It has no idea who's listening, and frankly, it doesn't care. It's just shouting its data. And any other part of the robot that needs that info, a subscriber, all it has to do is tune in to the right channel and listen. And you can see that one-way street in action right here. The publisher node is just sending out its messages on these specific channels, these topics. And any subscriber node that cares about that information just listens in. It is pure, simple, one-to-many communication. A perfect real-world example? Think about a robot's camera. It is constantly, endlessly streaming video frames. That's a topic. And here you can see the simplest version of it. The publisher on the left is just shouting "Hello World" over and over. And the subscriber on the right, it hears it instantly. It's a continuous, one-way fire hose of data. So shouting is great for general announcements. But what if one part of the robot needs to ask another part a very specific question and get a direct answer back? Well, that calls for a completely different kind of chat. And that's where something called a service comes in. So, if a topic is our town crier, a service is more like walking up to an expert, asking them a direct question, and waiting for them to give you a specific answer. It's not a broadcast, it's a dialogue, a two-way street.
Now, services are perfect for these quick transactional tasks where you need an answer right now. But here's the catch, and it is a big one. The part asking the question, the client, has to stop everything it's doing and just wait. It is completely blocked, totally frozen, unable to do a single other thing until it gets that reply.
And right here we see that exact exchange playing out. The client down in the bottom window sends a request with 2 separate pieces of text. The server at the top gets them, does its job, in this case sticking them together, and sends the answer back. Only then does the client wake up and print the result. A clean, direct, two-way conversation.
Okay, so we can broadcast information out to the world, and we can ask direct questions. But what about the really big stuff? The long, complicated jobs that take time? The missions. Just think about it for a second. You couldn't use a service for a long task, like navigating a maze, because the client would be totally frozen the whole time, completely blind to what's going on. For that, we need the big guns. We need our third and most powerful type of conversation, the action, or as I like to call it, the mission briefing.
An action is a much more sophisticated conversation. It's a whole 4-part process. First, a client sends a goal. Say, navigate to the kitchen. The server receives it and replies, goal accepted, mission is a go. Then, and this is the magic part, as it travels, it provides constant feedback, 50% of the way there, 75%, and only when the mission is totally complete does it send the final result. Arrived at destination.
This is what makes actions so incredibly powerful. It's the feedback loop. After sending that initial goal, the client isn't just sitting there blind.
As you can see in the bottom window here, it gets a constant stream of progress updates. The client is never, ever in the dark, which is absolutely essential for any long or complex mission.
All right, so we have our 3 types of conversations. But just imagine thousands of these happening every single second. How does the robot's brain avoid total, complete chaos? How does it know to prioritize an emergency stop command over just a routine sensor update? Well, it all comes down to a very strict set of rules.
These rules have a name: Quality of Service, or QoS for short. The best way to think about them is as the traffic laws for all this internal robot communication. They make sure the right messages get to the right place at the right time and with the right priority.
Let's just focus on 2 of the most important rules. First, you've got reliability. You can choose best effort or reliable. Now, for a supercritical command like emergency stop, you're going to want reliable, right? That message absolutely must get through, no matter what. But for a video feed, best effort's probably fine. If you lose a single frame here and there, it's not the end of the world. Then there's durability. This one's really cool. Imagine a part that's broadcasting the robot's location on a map. You'd set its durability to transient local. That way, if another part of the brain starts up late, it immediately gets the most recent map data without even having to ask. It's like the message is saved for any latecomers.
And for the ultimate level of control, there are lifecycle nodes. Honestly, just think of this as a pre-flight checklist for every single part of the robot's brain. Instead of everything turning on at once in a chaotic mess, each component is brought online in a very controlled sequence. First it's configured, then it's activated, and eventually it's deactivated. This kind of orderly startup prevents catastrophic failures if one component depends on another one being ready first.
So now, with these building blocks and these rules of the road in hand, let's go back. Let's go back to where we started and take one more look at that complex map.
That crazy map? It's not a mystery anymore, is it? We can see exactly what it is now. It's a mission briefing, it's an action. And if you look closely, it's built using the very tools we just learned. See, it kicks off with a service to send the goal, and it broadcasts its progress updates using a topic. The most powerful form of communication is really just a clever combination of the basics. We've cracked the code.
And there you have it. The robot's entire communication toolkit, its whole secret language, really just rests on these 3 pillars. You've got topics, the town crier, for one-way broadcasts. You've got services, the direct question, for a quick question and answer. And you've got actions, the mission briefing, for those long-term, complex jobs. We've cracked the code. We've learned the secret language. But what happens when this language is spoken by hundreds of different components all at once, under immense pressure, where a single miscommunication could mean mission failure? That is our next story. Harry Har,